OK, we can start. So you will be home in several days after the conference, and you will be very excited. And you should be excited because you will hear, and you have already heard, a lot great stuff about programming, about new technologies, new approaches, new driven developments, whatever you like. But then probably your enthusiasm will be broken because it's hard to go to work and be only one in the work that is who is writing, who writes tests in the test-driven manner. It's hard to, for example, re-implement whole application into the microservices architecture, or to introduce domain-driven design just by yourself. And I think that I can give you some advices that will be applicable whatever your project is, as long as it is programmed in objective-oriented language. My name is Marcin. I'm quite experienced developer, for nowadays standards for sure, because I'm working professionally about 8 years. I do a lot of stuff, or I like to do a lot of stuff. I'm playing and listening to some music. I'm reading some books, and I do a lot of sports, mostly related to bikes. And maybe we should go further with the presentation, because maybe it will be more interesting than me. If you already been on some talks, you will know you will know that there is a Slido application, and you can ask your question putting the code GeeCON in it. And I want to explain myself. I don't think that talks about DDD, TDD, event sourcing, and all the other stuff are not worth it. I think they are. They are great because they broaden your horizons. Even if you don't implement it, you can look at your software from this different perspective. If you can implement it, great. But I think that there is a lot of really good speakers in these topics. And what's more, sometimes I need to be closer to the ground. So I want to hear or talk about stuff that can be easily applicable without really big changes in someone's life. OK, so we can start with the first thing. In my opinion, bad code, or maybe not the greatest code, is caused sometimes by some fears. I think that there is a fear of or a habit to reuse as much code that is already written as possible. And it's not a bad habit in general, because we don't want to duplicate our code. But I think that sometimes we are mixing the reusing with overusing. And I will give you a quick example. Maybe first I will start with a bit of domain. If you ever worked in a Scrum-like environment, you probably have heard about teams and boards. There are boards which are created to implement a project. There are Scrum boards like this, or Kanban boards. And there is a number of teams on each board, because there are a lot of teams that are involved in single project. And maybe they are teams like Team Gamma here that are involved in 2 projects or more. Because maybe they are like a team that is design team, for example, and they are doing their work, then they're switching to a different project and doing another part of work. So they appear in the 2 boards. And maybe we can go to code. And we can see how it's implemented. We have a team repository that is returning. I will enter the presentation mode, maybe. It will be. Oh. Yes. OK. We've got this repository that returns the teams for a single board or for multiple boards. And as the legends say, every developer, every time that he is defining a variable of a method returning collection, he has that mental debate for an hour. It should be set, or should be list, or maybe map, or maybe it should be linked hash set. But what I see, it's always list. Then there is a bug. that there are duplicates in this list, and without looking why, we are just making a set. Then we have a bug that the order is random, so we are making the tree set. And I think that's the life cycle of a type of a collection in a project, collection type. And we can look at how this code is used. I will give you some really sketches of the code to not get too deep in the domain, but for example, we've got some business value. Let's say that this business value is how fast we will finish the project. And to calculate it, we want to use different team. For example, we are thinking what will happen if we will change that team to the other team. Maybe this business value will be better. So this is client of our repository. He's taking advantage that the teams is a list. He's finding the team to be replaced by index of function, and then he's setting the team. Like, as we are giving code to our clients, our colleagues in the company, we don't have a force to tell them how they should use it. They use everything that is possible. So maybe they use it wrong, but okay. It's not our job to look at every usage of our code from different teams. And the same function is calculated for the number of boards, because maybe we want to know how big will be this value, how this value will be if we will calculate it for number of projects. And as we have the list, the client thinks, okay, if the team is in 2 boards, maybe it will be duplicated here. So I need to replace every occurrence. And I still, after replacing every occurrence, I want this team to be only once in my calculation. So I'm making the hash set from that list. And then I calculate it. It's maybe not the best code, but as I said, we don't every time know how people use it. Then we want to calculate capacity of a team, but only for teams that have some members. So we are taking the team stream, filtering. It's quite straightforward. Then we have a report of a team in the context of a board. So we are taking the teams from the board, and we are looking for a team by ID. Then we have some query service because we want to find the teams. The client wants to provide functionality to search teams by names, by member names. So we make a stream, filtering, collect. It sounds quite easy. Then we've got the report service that is making reports for teams with members, without members, but we client need to have this case-insensitive order by name. Quite similar is in the resource for front-end purposes when we want to return some front-end friendly objects, and it's the same. We are finding teams, we are sorting them, we are finding by name, etc. And it's the same in members reports calculator when we have found teams, and then we are filtering it by ID. And what I see here is now a number of problems. The first problem is that there is a lot of collection-related code in every usage of my API, a lot. There is a lot of duplicates. I see that looking at this code that the client don't really know what he wants to expect. And even if, what's more, I'm unable to refactor it. So for example, if I will take this team repository and I would like to change the type to set, maybe I will do it, but I will break the code. So it's hard to refactor. Maybe there is a number of such usages, and I will need to discuss every such a usage with the owner of the code. So from my opinion, it's not a good design, and maybe we can do it better, and I will show you how I would do it, in my opinion, in a better way. Instead of returning collections, I will return my own classes, instances of my own classes. And to know if it's OK or not, I will just look at the usages, not the implementation. Here I've got teams, which as I said, it responds multi-board teams because it's for multiple boards. And if I say distinct, I will get the copy that will have only, every team will be here one time. I can make a copy, but with the team replaced, and then I can calculate it. It's even more straightforward for a single board. Then I have this capacity calculator, and I provided the function because it's my class, so I can provide as many other functions as I want. That returns only teams with members. I've got this report, and I'm finding team by ID instead of making a stream and filtering, which is really nice because I can make a map instead of list as a backing collection. So it will be probably a way faster. Then I have this report, and I can make functions ordered by name. I can search for teams by name if I want to. So I'm able to provide all these functions for my clients well named, and I can express more in this code, in my opinion. And I will try to briefly sum it up because maybe it's quite boring example, I think, for some of you. So the more examples would not help. First, I want to say that, of course, I made this point in the way that will prove me right. So if I think that maybe it's not a good idea, I'm not talking about this in terms of my idea. And pros. JavaUtil is well-known API. If you return a Java API, something from JavaUtil, every Java developer will know how to use it. We all know how to use set. We all know how to use list. In case of our own class, somebody will need to discover the API. There is less code. You don't need to write this wrapper. It's compatible with external libraries. For example, if you want to put it in this, for example, Spring framework or in some other framework or a util class like Apache Collections, then if you will use wrapper, you will have to make it a Java collection, for example, to have a method to list or something that will return you a real Java util collection. What are the cons? There is a bit of code duplication, especially in terms of code related to collections. There is no explicit information about order or duplicates, and what's more, it's hard to give that information. Even if you make tree set, we have no idea how it is sorted, because as soon as we're creating the tree set, the information is gone. So then, using the naming of a class, for example, we can provide that information to the client for a code. There are mutability problems. If somebody is returning as list, we can use every mutating method on that list. And even if you don't want us to mutate it, and he will return as an immutable copy, the most probably the problem will be in the runtime, because he will return as a list that is wrapped in immutable wrapper, and it will not work because we will still see every method as possible to call. And we've got refactoring problems because as soon as we return the first instance of that list, we are saying the client of our code, you can use every method in the collection frame interface and the list interface if you want to. If you look at this interface, you will see that you are like making a really big contract with your client. In terms of wrapper, the pros is that we can use meaningful naming for class and methods. Code-related collections is in one place. It's easy to handle immutability. In my opinion, easier to refactor. There is less duplication. It's overloading friendly. For example, if you have a method like this, and you want to overload it with other method that has a list, but for example of integer, it's impossible because this generic type is erased. And if you have these wrappers, it will be possible if you are a fan of overloading methods, as not everybody is. And there is probably more code because you need to write this wrapper. And when it comes to cons, and there is a danger of accidental duplication, which is really important to know about. For example, we've got this method find by name. And maybe one client of our code wants to find the name in case-insensitive way, but the other in the case-sensitive way. If we are providing them with that method and we are unable to solve their needs both at the same time, we can make a flag in that method. But in my opinion, it won't be a good design. So you shouldn't be functionality eager, greedy. to take everything that I can to this wrapper because it's really tempting. Like, I will put every calculation there. Everything that can be used by client, I will use there. And that's a bad path because it causes accidental duplication. If you read a clean code or clean architecture, I don't remember in which one this topic was mentioned. Accidental duplication is the situation when you want to deduplicate the code. So we want to unify it in the single method, the code that shouldn't be unified. We just accidentally thought that it's the same calculation, but it's not. OK. The second part is about inheritance. The second tool in our Swiss Army knife of the object-oriented programming. I think that average developer, when he is thinking about creating interface and creating subclasses or implementation of that interface on abstract class, he is trying to make it in this strange way. For example, we've got only 2 types of boards, Scrum board or Kanban board. But we are making the code like maybe tomorrow there will be 2,000 types of boards. So we are acting like we don't know that there are specific concrete types. We want to be as abstract as possible. And I want to talk about it a bit. I made this table. And in my opinion, there are 2 problems, 2 types of problems that are solved with inheritance, extending, etc. We've got fixed number of subclasses, and we are sure that there are, for example, only 3 types of implementations of interface. Like with the boards, we've got Scrum board or Kanban board. And if we'll introduce the third one, it will be a really big deal. It will change the way our application work, and probably will never happen. On the other side is that the number of subclasses is unknown. If you are making the framework like Spring, you don't know how many initializers there will be. What's more, you don't even know if there will be any. Like, you have no idea, you can't even check it if you are a Spring developer. So, in the first example, what usually change is our functionalities. So we want it to make it as easy as possible to add new functions to that interface. And maybe someday we'll add new subclass, but it's not our main goal. So our design goal is to make ease of developing these new functionalities important. And with the other one, the thing that is changing is number of subclasses. We can say that the more subclasses clients will implement, the more powerful, the better our software, the richness of our software will be. And our design goal is to make that developing new subclasses as easy as possible. And I will talk about this in examples. So, I will briefly introduce you with a domain. If you work, again, in Scrum or Sprint-like environment, and you have a Scrum Master in your team, probably you have defined the sprint goals. We have a team, for example, 6 people there, and they have like 15 tasks in the sprint. But they want to define something closer to the business, so they are defining goals. Like, they are taking like some tasks and making it a goal. For example, we are having like 10 tasks that are making our performance better. But we don't want to say to business like, this method will be faster. We're just saying like, OK, this module of an application will be faster. Or for example, we have, for example, number of libraries that are outdated, and we want to update them. So our goal will be to have all the libraries up to date. And there are some characteristics of that objective. It's an owner because we want to blame somebody if he will fail. There is a value because we want to prioritize it a bit, and there is a status because we want to know if we succeed or we failed or we still don't know. And there are 2 types of goals, only 2 types. One is handwritten. We are just typing the name because we see 10 tasks. OK, we will make some some name that will connect them, or maybe one of the tasks is exact our goal. And we don't want to like rewrite and copy paste the name. We are just selecting this task and saying it will be goal for that sprint. And as you see, this task is pretty. It has an icon, hyperlink, etc. And I will show you how it looks in the code. We have this goal interface. And as I said, it has an ID, value, there is an owner, there's a status. And sometimes we want to treat these goals uniformly. So, for example, when we are checking how many goals we were able to deliver. So we want to just have a collection of goals, not two collections of handwritten goals and second collection of task-based goal. And if you look at the implementation, there is a name in a handwritten goal because we typed it in the keyboard, and there is a task ID because we selected the task in the task-based goal. And we can look how other aspects of software are implemented or the usages of the domain. For example, we've got goal storage. You want to store the task-based goals and the handwritten goals in separate database tables, maybe for some, not only for clarity, but also for sake of, for example, performance or whatever, different indexes, etc. And to do it, we need to check what's the instance of. If we have newer Java, we can use that in-place declaration. It's maybe quite nicer, but if not, we will have to make a casting here. And it's like a branch that I suppose that most of us have one time in their life see. This if goal instance of X, if instance of Y, and as many subclasses as there is, we are making this, this branch, if branching. Then we have exporting service. For example, we want to export the goals to the spreadsheet because management want to see them. And every row is a single objective. So we have, with a task-based goal, we want to take the task name from the task. So if it's task-based goal, our second column will be name of the task. If it's a handwritten goal, our second row will be just a name that we have typed manually. And it's the same if branching, but with surprise that there is, we need to throw new illegal argument exception or use, for example, optional here if the type will be different, which is not expected by us. And the last thing is the resource for front-end purposes. We want to convert our goals to the front-end friendly objects. We call them DTOs. And we've got this converter that in terms of task-based goal are returning the whole task in the DTO to have this pretty display of the task. And in case of handwritten goal, we are just putting the name there, here. And in my opinion, this code is, I don't like it. The problem is, there's a number of problems. The first one, we have this same branch every time. The second is that we did have this strange throw illegal argument exception thing. So we need to deal with a situation that will never happen, for example, but it needs to be in the code. It needs to be in the code. And if we one day will add a handwritten goal, another type of a goal, for example, GeeCON goal, maybe sometime it will happen. It will be hard to find all the places where this if tree is. So maybe we will miss for some subclass we will miss the implementation, and then it will appear in runtime because there will be no compilation error. In my opinion, we should use something which is hated a lot in a number of presentations that I have seen. It's a visitor pattern, and visitor pattern is really easy. If we have an interface and we don't, for example, we can use it to avoid instance of clause. We've got an interface that is returning a generic type, and we are implementing overloading visit method for every concrete type of a goal. And it's quite easy interface. And then in every concrete, in the interface we need to have a method that's generic as well. It's accept, and as a parameter, it takes Go visitor. And in every concrete implementation, we need to make the same implementation, accept, of the accept method, which is visiting the visitor with this. And here is the whole core, the trick of that pattern, that this, in this context, is type of this is known. It's task-based Go. We are unable to use it, for example, in an abstract class, because if we will try to do this, there is no way for Java to know which method it should call, because this is of type abstract Go. So we need to implement this. It's in the same way in every concrete subclass. Maybe it's not really comfortable, but it's a price that I can pay. Okay, and now we can see how it's used. Of course, this return no doesn't look nice. We can avoid this, but for the sake of example, maybe it will be easier like this. And what is really nice in this code, and I really like, if I want to implement something like this, my development environment is guiding me. It's generating this tree branch for me. I don't need to remember how many subclasses I have, because it's defined in that visitor. What's more, I don't have this in the other places. I don't have this strange illegal argument exception clause. And I really like. Maybe someone would say, but it's the same, but in a different structure. Because yes, we have almost the same method here, but like it's driven by compilator more. Because our code will not compile if we will not implement all the visit methods. What I really like in this design too is that every new functionality is just a new visitor. So it's really to implement them. And the other thing is that if we will ever add a new type of goal, for example, we will make GeeCON goal, and we will add it to our visitor. So we will have the same method, but with different type. Our environment and compilator too will tell us that there are 3 places that we need to implement a method. So it will drive us to implement all the methods that are needed in case to fully handle this new type of goal. And of course, there are alternate solutions. The one is the polymorphism, one would say, and just add these methods to Go. But I think that it's breaking vertical boundaries. It's breaking dependency inversion principle, because then the abstract class will know about details, how it's used. Like maybe Go shouldn't know how it's exported to spreadsheet. It shouldn't know how it's stored in the database and how it's converted to DTO. So this is a solution that I don't like. The other one is to have a separate path. I can think like I know that I have only 2 types of goals. So I will write AP method different for every type. Separate method for every type. And in my opinion, it will be hell. Like, I never tried it, and I don't want to, but I think that the number of duplicated methods will be huge. And adding every functionality will mean that we, without the guide from the development environment, we will need to know how many methods we need to implement by heart. It will be, in my opinion, hard. Okay. And as we saw before, in my diagram, there was also the situation when we have an unknown number of subclasses. And I made like imaginary app in my head. And this app is about machine learning. If you ever written any classifier or make any machine learning task in your work during the studies or for hobby, you probably know what this will do. We are selecting the classifier, we are uploading the data, and if we will select the classifier of, for example, nearest neighbors, then we will need to put the number of neighbors and type of distance. If we will select linear regression, we will have different characteristics and parameters of a classifier. At the same with decision tree, then there should be a button like a classify, and we'll see the result, how how this method performs. And if we want to extend that application, we want it to be better, the user needs to implement a classifier. So, for example, we have built-in tree classifiers, and if a user wants to, for example, I don't know, maybe random tree forest classifier, he needs to implement some interfaces, and then it will be available in the app. And we can see how it's implemented. We've got the classifier that classifies a vector to a class. We've got the classifier configuration interface, because every such a configuration will be of different type. Converter, because from our front end, the configuration will came as a JSON, and we want to have a strong typing, so we will we'll make this, we'll convert this JSON to a configuration, so we need to write how it will be done. We've got repository to save that configuration. We've got classifier factory that is returning our classifier. We have metadata provider to be able to display something on the UI, because we want the name and description. And as you see, every such interface that needs to be implemented is returning the classifier type ID, because then we will be able to look up for it. And the problem, I wrote code like this, and my colleague told me, okay, what if I forget to, for example, implement this classifier metadata provider? And I told him, like, probably it will fail in runtime, but you will know how many interfaces you need to implement. And he told me, okay, but why make it so hard? Like, why people need to know about 4 or 5 or 6 interfaces to implement? Maybe they should know about 1. And he told me, like, take all these interfaces and put in a single class that you will call classifier provider. And if user will try to implement it, he will need to deliberately return null to make it fail. If you implement all the methods and he will return real objects, the classifier will be implemented. And of course, as with every review, I told him that it's a stupid idea and I will never do it and my code is better. Then I came home and think like, okay, it's a really good idea, and how I will now tell him this in the way that it was my idea at the beginning and not his. And my stupid idea was his originally. And so it was quite hard to do, but he's a smart guy, so he let me believe that it was my idea for the sake of argument. And that's what I advise you to do if you have such cases. Like, if you have unknown number of subclasses, and for example, this unknown number of subclasses make people to provide one new functionality, they need to implement number of them, number of such interfaces. Like, give them this single point of implementation to let the like with the visitor, to let the IDE drive them, and it will make their life easier. Okay, so in my opinion, summing up, it's good to know what kind of inheritance we are dealing with, because then we can choose the right tools, we can choose the right designs to support the thing that we want to support deliberately. Okay, and there is last but not least thing. I called it Entangling concepts, and I will show you an example, and it will be as abstract as possible. So probably you will hate me for it, but maybe you can use your imagination and think about any action that your application is doing, like scheduling tasks, or calculating some business values, or, for example, picking the right node to run the function on, whatever. And instead of seeing here an action, an object, just name it in your mind. I'm naming it the scheduling service, and for me is a task repository that will schedule it. And we've got this function perform, which is quite complicated because it has a lot of functional and non-functional requirements that are in the one place. Maybe we'll start with this action is disabled, as request is operating on some object. We are checking if this action is available for that object. Maybe in the configuration of app, it's said that for that particular object, we will not support this action. And if it's not, we want to return optional empty result. Then we need to check privileges for that object if logged user has it. And if not, we will throw an exception. Then we are performing finally our operation. And what we need to do is to log time of that operation, because it's really important for a customer to have this logged for monitoring purposes. And we are trying to do it. So the problem is that we have this early return, so we need to have to measure finish differently for each of these branches in the if. For me, this code is not good, and like of course it could be better even in this form. But for me, the problem is that we are mixing the business requirements with some non-functional requirements. So, for example, measuring the time with the calculation, or checking security with a calculation, and we need to wait like 1, 2, 3, 4, 5, 6, 7, 8 lines to the 8th line of code of the method to see the perform action and to know that this is the important thing, because probably the most part of our effort will be put to implement this perform action. And what I like to do in such a situation is to make that action a command. It's a design pattern, a command pattern, and to create it in the factory. And I will just show you the action. Action is just an interface that is returning optional result. If we see at the implementation, for example, the main implementation, it's just taking the object and performing the operation. And this whole action imp is just about calculating the business thing, nothing more. And then we are going to the factory to see how it works. First, we need to create an action. So if the action is unavailable, we will create, if it's available, we'll create this action that I showed you before, the real implementation. If it's not available, we create the instance of a null action. It's a null object pattern. And we have this raw action. Then we'll wrap it in the security proxy. So before we will do any calculations, we will first check the privileges, if we really can do it. And if not, there will be exception. If yes, we will just call the method of delegate. Then we've got this logging action. So our code of logging time is really simplified, and it's in one place. It's not mixed with other concepts. It's not mixed at all, and we don't need to think about different branches, etc., etc. Of course, we need to think about it here. But not in the different places. In the factory, yes. And what's more, for example, if this action is idempotent and we can call it number of times without any side effects, we can cache it. So if we perform it first time, we'll return the result that we will calculate. But if the second time, we will return a already calculated result. So we have some extras when we choose this path. And when it comes to this factory, of course, most of you will say that all these concepts are already addressed by, for example, aspect-oriented programming or frameworks which use aspect-oriented programming like Spring, etc., etc. But I believe that there are other concepts in an application that you can see that can be solved this way. And of course, this example is made on purpose to show how to do it. to not make you uncomfortable with the code that you don't know, for example, from my domain. And of course, one can say that I moved one mess to another place. Yes, I did it. And of course, it's better when there is no mess, because this code is a bit of mess, I admit it. But what I achieved by moving this mess, I reorganized it. So the concepts are not tangled as they were before. Like the security, if I look at the security proxy, is dealing only with security, nothing more, nothing less. Logging is dealing only with logging. It's not mixed with other code. So for me, it's really important to have these concepts untangled. Okay, and I will give you a brief summary which patterns I have used. The factory, the null object pattern, the command pattern, some decorators and proxies. You can discuss which one is decorator, which one is proxy. Maybe one could discuss whole night because there are different definitions for every one of us. Okay, and to sum up, I think that we can sum it up in 3 points. First, use strongly typed collection instead of Java util collections, especially when we are talking about public API. Of course, your object will be backed by Java util collections, so use Java util collections. But maybe if you are making a public API, return your own class, your own interface to make people able to use your code as you designed it for. And you need to remember about logic boundaries to not be functionality greedy. The second advice is about inheritance. Like, be really aware what type of inheritance you have. Maybe you have this fixed number of subclasses, maybe you have this unknown number of subclasses. And if you have that knowledge, if you can admit that you will not make the most abstract code ever, you can help clients of your code by using visitor pattern in the first case, and maybe the single point of implementation in the second place. Of course, you're really smart and you can invent better tools to do it. But in my opinion, it's the most important to know where we are, what type of inheritance we will design. And the third one is to untangle unrelated concepts. By using null object pattern, proxy, decorator pattern, command pattern, factory method will help you to create these things, to orchestrate it, etc., etc. And with all these advices, is as with all advices, use it wisely. Don't use it for the sake of using it, and always think critical. If your code will look ugly after using these tips, just revert it. Don't use it. Like, the only purpose of this advices is to make code cleaner, easier to understand, easier to extend instead of modify, to just to make your work easier. If it doesn't serve this purpose, just revert it to your form. Maybe it's way better than the things that I proposed to you. Okay, and that's all, but we've got we've got some questions. You can use slide now. We've got one question. Okay, what are these tiny annotations? To be honest, I tried to turn it off before presentation, but I don't remember what plugin is it. So as I was striving to prepare for the talk, I just said like, okay, I don't check it. But Marcin, I can tell you after talk. Just we'll find it in my ID. Okay, I don't know if I don't need to refresh it, probably. So there are no. Oh, it comes with newer IntelliJ, new version of IDEA. Oh, so it's, yes. It's application not only for question, but for answer too. So it's a real Q&A application. Okay, so if that's all, I think that I can let you go this 5 minutes earlier, and you can enjoy Krakow as I am. So thank you.